Hello everyone, how are you all? Welcome back to the channel. Today I'm here with session number 1 in the chapter Continuity and Differentiability. So as you know, this chapter is high weightage, so of course the session is very important, but I have one more reason to say that. The reason is very simple. This is the step number 1 in the entire unit of calculus, right? So you know that very well. If you talk about calculus, one of the high weightage unit from your PU2 or your KCET examination, both, even you know that PU2 is very important, so of course it makes a very big impact in overall score and rank in the CET 2026 examination that you're going to take. Okay, so this is very important in that regard. Now if you're somebody who's struggling with the limit section, don't worry, go ahead, watch my bridge course. I've already covered there the limits in detail. You can learn that if you are having any trouble. Otherwise, don't worry, whenever the question has limits in it, I'll try to give you some explanation over there also. Okay, now before I start with the session straight away, I want to say one thing to all of you, that I want to thank you for your participation. You are doing a very good job. Looking all of you over here present in the classes, watching the sessions, it makes me very happy. It shows your commitment, your motivation to be present in the class, to watch the session, to learn from the session and make a serious change in your preparation, serious improvement in the preparation. But I'm telling you, you have to be very consistent. How can you do that? Watch the entire session and solve each and every question. Look, in the beginning you were asking me, sir, there are less questions in the actual concept session, so I gave you more problems. So I want, by the end of the session, you should give me how many questions you got it and you solved it. Okay, and if you have missed some, don't worry, download the class notes from the WhatsApp channel and again attempt it 1 or 2 more times. Okay, but your goal is to completely solve all the questions that I'm giving you, whether it is your normal classes or CET or JE, whatever it is, you have to solve all the problems. Otherwise there's no point of me giving those questions to you. Okay, now why I'm doing all of that, why I'm saying to you all of this, because if you do this for a few months, you'll see a big difference, big improvement in your preparation, in the student that you were and how you're dealing with the mathematics. Trust me, if you do that, you will be across among these rankers next year. This is the result from our KCET 2025 results. Okay, so you can see all the names. We can't put all the names, so we have kept some over here. Okay, but we want you to be part of our next year's journey of KCET 2026, and that can happen only if you are consistent in the process. Okay, so believe me, trust me when I say these questions are very important. At Deeksha Karnataka, we don't joke around, we don't kid around. We are very much committed about our work. Okay, everything is taken very seriously over here. Every single comment of yours is taken very much seriously over here. Okay, there are n number of content providers, channels on YouTube right now where you can go and time pass, but on our platform on Deeksha Karnataka, we take care of the students. Okay, we are very much committed to what you need and how can you achieve that dream score of yours in the next year examination of CET 2026. Is that clear to all of you? Okay, if it is clear, let me know. It is very much clear, sir. And I want one more comment from all of you. By the end of the session, you should tell me how many questions you got it right. Okay, you got 5 questions, you got 6 questions, you got 10 questions. Every session I'm giving you 5 to 10 questions, right? Sometimes I give you more than 10 also. You let me know how many questions you got it right. I want to know your names, because when I start the live sessions, I want to know who are the students who are doing it right. Okay, so I want to know your name, so please leave your answers, your number of questions you got it right or wrong in the comment section. I want to know all of you. Okay, next, so of course in the session today, if you want to know what is there, we're going to start with the very basic thing. We'll be starting with definition of continuity. Okay, and then we're going to move on to algebra of continuity. Is a simpler concept. It will take 1 minute to cover that part. Don't worry, we'll see questions on that. I have questions on that. And next we're going to go to continuity and interval. It's again a very important topic from the competitive examination point of view. Next we move on to types of discontinuity. Okay, remember removal, non-removal, types of discontinuity, and then we go to question practice. I've taken more than 10 questions to solve that, and of course I'm going to give you homeworks also. Not just the questions, also you'll have the homeworks. So I think we can start now. All of you ready? Leave me a comment right now. Ready, sir. Okay, so don't worry, even though it's a recorded session, I'll see your comment. I'll reply to your comments. Okay, let's begin with the session now. So as you can see, when we talk about continuity, okay, there are a lot of things written on the screen, you can remember that, but I'll give you 3 important steps. Step 1, step 2, step 3. Step number 1. Step 1 is to check the limit of the function. Of course, whenever we talk about continuity, we talk about continuity of the function at a point, right? At a point, for example, think about it. Over here we have mentioned at the point x equals to a. So for that point, x equals to that point, find the limit value. Find the limit value at which point? At the point x equals to a. That's step 1. Step 2, find the function value at that point. Step 1, find the limit value at that point. Step 2, find the function value at that point. And step 3, are they equal or not? Are the limit value equal to the function value or not? If equal means you'll say limit exists. Sorry, not limit, you'll say function continuous. I went into the limit part. Just give me 1 second. I'll make this change. You'll say what? The conclusion is continuous. If your limit of the given function at the given point is equal to your function value at that point, you'll say the given function is continuous. That much. Okay, same thing I've written over here. 3 steps: find the limit, find the function value at that point, and third thing will be check whether they are equal or not. If you can get that right, that is enough to check for the continuity, nothing else. Okay, so you can see over here fa is defined means function value you find, and limit is existing. Of course, limit should be found out, and you check whether they are equal or not. If they equal means the function is called to be where the function is continuous. Okay, and that point is called as point of continuity. This point, no, x equals to a, this point will become, if the function is continuous, it will become point of continuity. Clear? This much is clear, right? Okay, very simple things. Next, can we move on? Discontinuity at a point. Now, so we learnt so far very basic definition. When can we say for a given function that it is continuous? Now, let's move ahead, just opposite direction to this. When can we say a function will be not continuous? Okay, because both kind of questions can be asked to you, whether it is continuous or not, right? Not continuous means simply called as discontinuous. So let's talk about discontinuity of a function at a point. Okay, this function can be a modulus function, this can be a trigonometric function, this can be again various different type of function that we have already learned. Don't worry about that. But right now, for any given function to you, when can you say the function is discontinuous? So again, if you want, we have listed here the points, but if you remember the 3 things that we learned in the first slide, if those conditions are fulfilled, the function is continuous. If any one of them is missing, it means the function is discontinuous. I'll repeat myself. If the 3 conditions I gave you are fulfilled, always fulfilled, it means function is continuous. If any one of them are not fulfilled, then function is discontinuous. Think about your first one. Limit, what does this represents? If you learn the limit, you'll know it's called as LHL. A minus is there, right? So LHL. LHL, this means RHL. What is the LHL, RHL? Left hand limit and right hand limit. So LHL or RHL both may not exist. May not exist means what? It means simply this will imply, sir, limit does not exist. If any of the left hand limit or right hand limit does not exist means simply limit does not exist. This is my first point. I told you my first point here, limit should be existing in nature. What I get from the first condition, the type of discontinuity, okay, that limit does not exist, it means the function will be discontinuous at this particular point A. Second, they are both existing in nature. Limit LHL and RHL exist but not equal. Remember, I've taught you that when can we say limit exists? When we have LHL and RHL both defined and they should be equal also. But we are saying what? LHL and RHL both exist but not equal. What it implies? Again, same thing it implies is limit does not exist. Limit does not exist. Okay, so again we have the first condition which is not fulfilled over here. Limit is not there. Limit is not there. It means, of course, the given result will be, the given condition will not be continuous at the point. The last one, limit fx and limit f, basically LHL and RHL both exist and are equal also but not equal to fa. Which condition is this, sir? So limit exists. So basically the condition is now limit fa or basically fx when x tends to a exists but not equal to f of a. F of a. This is my third point. Please check. If it was equal, we'll say continuous. Here we are getting not equal. I hope you are able to relate to that. Okay, can we move on now? Let's try. Next we have one question to understand what we have learned. Okay, so yes, learning is one thing, but really understanding means you should practice some questions on it. Let's see a question. So examine the continuity of a function fx equals to 2x square minus 1 at x equals to 3. So this is a parabola, right? It's a quadratic, it's a parabola. Y equals to 2x square minus 1. If you know it is a parabola, it means you all always know that if there is no point of discontinuity, means if the function is defined for x belongs to all real number, right, it means it will be always continuous. It will be always continuous. If you know this much about the functions, okay, your answer is simply it's a parabola, quadratic function. What is the domain? Domain is all real. You can put any value for x, and at everywhere the function will be continuous. So answer is continuity is true for at all the points in the real number. It means even true for at x equals to 3. Is that clear? Right? Now, but if you want to use the approach of limits, you can do that. Remember to find the limit for this thing. Any problem? No, because there is no indeterminate form. There is no indeterminate form. Simply substitute in the function x tends to 3. You're going to get this as 2 times of 3 square minus 1. Simply 9 into 2 is 18 minus 1 is 17. And even if you are finding function value at 3, it will become 2 times of 3 square minus 1. Answer is 17 only, and they are basically equal. Limit is equal to your function at 3. Right? It means the given function, which is a parabola, which is a quadratic, is continuous at the point x equal to 3. So either you can use algebraic approach, or if you understand the graphs, you can understand this approach also. So where is the graph? I have not drawn it, but you know that, right? It's a quadratic. The graph will be parabola. The graph will be parabola. Clear? Parabolic graph defined for what is the domain of parabola? All real. Domain of parabola is all real, sir. Okay. So question number 1 is done. Simple question, very much simple. Let's move on now. So next is algebra of continuous function. Is it difficult, sir? Looks difficult. If you know it, you'll know it is very, very simple. But if you are somebody who's learning this for the first time, you might feel that it is difficult. But I'll tell you, very, very, very simple. Condition is, there's only 2 conditions. There are 2 functions f and g. They should be continuous, okay, at the point x equals to a. That's all. There are 2 functions given to you, function f and function g are the 2 real functions, okay, in the variable x, and they are both continuous at the point that we are looking to define the algebra of continuity. Okay, got the condition? I'll repeat myself. The given function should be continuous at the point. Both of them should be continuous. Okay, if that is done, then what we have, f plus g will also be continuous at that point. That's it. If f is continuous, if g is continuous, then f plus g will also be continuous. Next, same goes with f minus g also. F continuous, g continuous, then f minus g also continuous. Same goes here in the case of product also. If f continuous, g continuous means f into g will also be continuous, and this completes the first 3 points. Let's move on. F by g. Again, f continuous, g continuous, then f by g will be continuous provided g of a is non-zero. Why, sir? Put it here. Undefined, sir. If you put g of a as 0, it will become f by 0. Hence, undefined. So, of course, it will be continuous provided for all the cases when g of a is not 0. If it is 0 means it will not be defined, of course. Okay. Then f by g will be continuous at the point. Only one condition is g of a not 0. K of f. What is k? Is a constant. K is any real number, any constant number. Then if f is continuous, then k times of f will also be continuous. You want to see an example? Y equal to x. Y equal to x. What does the graph look like? This. That's your graph. So if you write y equal to 2x, what will happen? The graph will be continuous only, right? The graph will change a little bit. Okay. When x is 1, y is 2. It will go steeper, right? It will go steeper. Y equal to 2x, y equal to x. Are these both graphs continuous or not? Is there a break in the function? No, nowhere there is a break. Okay, so whether you take any constant multiplied to the function itself, will it change? Of course not. So if f is continuous, then kf will also be continuous. And next topic, this part is about composite functions. Composite functions. So this here talks about if again f and g are real functions and they are saying that fog is defined, means FOG basically is this operation is defined actually, means the result of the function is defined, it is a definitive function. Once that is known and they say that g is continuous at the point A, please listen to me carefully, g, the function which is inside, is continuous at the point A, and f, the function outside, is continuous at the point g of A. F is continuous at the point g of A. If this case is true, then you will say fog is continuous at the point A. Then you will say fog is not what we see, okay, the perfume is continuous at the point AK. Okay, got it? This is the FOG composite function f of g. Okay, f of g, I hope you know that. Okay, so for first thing is we have three conditions over here that should be fulfilled. Fog should be defined. Second thing, g should be the one which is inside, the g function should be defined at the point A, and the function outside should be defined at the point GA. Then you say fog is continuous at the point A. Okay, sorry, yeah, at the point A. All right, sorry, I was telling defined, right? I mean that continuous only. The word is continuous, not defined. Got it? We're looking for continuity, right? Okay, simple things only. Let's move on. Now, very important topic. This is very, very important because questions will come from this. Okay, any challenging questions coming your way can be asked from this topic. If I have to frame a question difficult, I'll frame from this topic. Continuity in an interval, especially for the closed intervals. Especially for the closed interval, because for open interval it is very easy. If you talk about open interval, it is very easy. How come, sir? So when we say open interval, I mean that what I mean is here A, here B. This is, let's say, A, this is B. Open interval means all this is there except for A and B. Correct? So for a given function to be defined in this continuous in this open interval, I should have continuity true at every point between these two. How many points are there between A and B? We'll have infinite number of points. At every single point, the function should be continuous. Then we can say the given function f is continuous in the interval A, B open. So I think same thing is mentioned over here. Function fx is said to be continuous in an open interval AB if it is continuous at every point in the interval AB. Okay. Now what about closed interval, sir? Then the story changes. For closed interval, this point should be, of course, true. That's the first point. When we talk about closed interval, this is closed interval. This is closed interval. Then what will happen? You'll have A over here, you'll have B over here, and this will be what? This will be closed. You'll have closed interval. Then the story changes. What is the story then? In that case, at the point A, your RHL at the point A, your RHL should be equal to f of A, and at the point B, your LHL should be equal to f of B. Means apart from every point the function should be continuous. That is a mandatory, of course. Okay, that is a mandatory, of course. Check this out. F is continuous on the open interval AB. Same thing, right? At every point it should be continuous. Apart from that, you should also have, what is this? This is my RHL. RHL should be equal to f of A, and my LHL, this is what, sir? LHL should be equal to f of B. Can you find LHL at the point A? Can you find LHL? You can't, right? Because you have to go beyond the interval. You can't do that. That's why you end up finding only RHL and put it equal to f of A, right? And for the point B, you find only LHL and put it equal to f of B. I hope this is clear. Is this clear or not? Yes. Okay. So this is very, very important. You're going to use it in the question. So please make sure that you are able to understand this very clearly. If you did not understand, let me know in the comment section. I'll come back again in the next session and explain it to you. Okay, let's move on. Important notes. Few important notes about the continuity. A function fx is said to be continuous if it is continuous at each point in its domain. In its domain, okay, because we're talking about the function itself. Okay, for example, I can take y equal to mod x, continuous or not, all first, sir. What's the domain here? Domain is this function. Domain is all real, sir. How the graph looks like? Have a look. This is my graph, sir. Is there a break in the function? Is there a break in the function? Of course not. It means it is continuous everywhere. Okay. So if in the domain a given function is continuous at every single point, then you'll call the function to be continuous. Okay. A function which is continuous at entire real line, okay, is said to be continuous everywhere. What it means? Same thing, right? We can apply the same example over here. This is what? This is entire number line, right? All real only. So first and second point can be used with the same example. A function fx is said to be discontinuous on an interval if it is even discontinuous at one point. Let's say I have an interval like this. So everywhere it is continuous except at this point it is open and then again continuous. This is, we can call this to be point of discontinuity. Then what will happen? Then it will become a discontinuous function. Please check. The function fx is said to be discontinuous on an interval if it is discontinuous even at a single point in the interval. What's the interval over here? Interval is again same thing. Please check. Negative infinity to plus infinity. At even one point, if you find the point of discontinuity, then you'll say what? In this interval, the given function is discontinuous. Got it? Last point. The set of all the points at which the function is continuous is said to be point or domain of continuity. For one point we call this as point of continuity. For the entire set of all the points is simply called as domain of continuity. I hope this is clear. Please check. This is clear, right? Okay, let's move on. Now I have listed on some functions. You can note it down, otherwise simply I will give you the class notes. The PDF will be given to you in the WhatsApp channel. I hope you have joined it. Get the class notes from there. Okay, so you can see a constant function where the interval is continuous, all real. We have again linear functions or identity function equal to again all real. We have quadratic functions or polynomial function, again all real. If you move on to rational function, except for qx equal to 0, that point will be not part of your domain of continuity. And for modulus, again all real. For x power minus n, basically again rational form will come, all real. Positive power of the integer 1 by x. So basically like this, 1 upon x power n. Whenever x is 0, it will be undefined, right? So again there are some more functions: sine, cos, e power x, tan, sec, okay, cot, cos x. I have listed all these functions domain where it is continuous. Download the class notes and go through it. It's important. Why? Because you don't have to find all the time. If you know it, it will be helpful to you solving the questions a little faster. Okay, can we move on now? Let's move on. Okay, all right, all good? Yeah. So now types of discontinuity. This is very, very important. I've taken a question also on this. We'll solve it right now in detail, don't worry. But it's very important again from the point of view of competitive examination. So there are two types of discontinuity. One is called as removable type of discontinuity. Removable type of discontinuity means, yes, there exists a discontinuity but can be removed easily by redefining the function. By redefining the function. For example, this one, please check. Y equal to sin x by x. Can you define this function at 0? Okay, we can find the limit of this. We have learned to find the limit of this. Limit of sin x by x when x tends to 0 is, sir, 1. We know that. It's a standard limit. But what about the function value, sir? F of 0 will be undefined directly. Okay, undefined directly. So what we do over here is we define the function. Okay, we break the domain over here in two parts and then the function becomes continuous. I'll show you. Okay, so right now this function is having a discontinuity, but the type of discontinuity is removable discontinuity. This one has removable discontinuity. Okay, how can we remove it? By, as I said, by redefining the function fx. So what is the function given to us? Fx is given us to sin x by x. We can define it like this: fx equals to sin x by x, okay, for all the x not equal to 0, for all the x not equal to 0, and for x equal to 0 it is simply 1. Now as a student you might be confused, sir, how can you say that? Okay, it's simply, isn't this the same value as the limit? Are you using that from the limit? I can use from the limit also, but I also have a concept that I can tell you. For a small, what is 0 means? If I see a number 0 on the number line, what it means? It means if I go right before or right after 0, what it means actually? It means that for, we are using this concept, for small value of x, small value of x, your sin x actually becomes equals to x. Your sin x becomes equal to x. For very, very small value of x, the sin x becomes equal to x. In that case, what happens is, please check, you will have x by x. You will have, this thing will be simply x sin x by x will become x by x. Cancel this out, you will have the answer as 1. Okay, so this is the understanding behind this change in definition. Okay, that's how we redefine the function. How I did, I have explained it to you. Okay, by taking very small value of x, you can see that, why small? It is close to 0, right? Okay, so for a very small value of x, what happens is sin x becomes x, so they will get cancel each other and the value will be 1. Now when you redefine the function like this, see the difference now. Is it continuous now? Let me remove all of this. Okay, just to explain you, I wrote. Okay, now after redefining the function, have a look. So let's check for the continuity. Let's check for the continuity part. So limit is what? Limit value is 1. Limit of the function when x tends to 0 is 1, and also function value at 0. F of 0 is what, dear? F of 0 is what? 1. So they are both, limit and the function value is coming equal to 1. So this type of discontinuity is called as removable type of discontinuity. Removable type of discontinuity. Easily removed by redefining the function. This is clear. If you're having this doubt, okay, any doubt in this particular concept, you leave that in the comment section. Whatever it is, I'll explain it to you again. Don't worry. Okay, is that clear? Is this clear or not? Okay, so let's move on. First type is covered, removable type of discontinuity. Second one we have non-removable type of discontinuity. Non-removable type of discontinuity. Okay, again this has two kinds, of first kind, of second kind, of first kind and second kind. Have a look. Both the limit LHL and RHL exist but not equal. But not equal. Okay, then this is again called to be, fx is a non-removable discontinuity of first kind. And second one, if the limit only does not exist, when the limit value LHL RHL does not exist, then we can simply this call as non-removable discontinuity of second kind. Very simple. When the limit exists but not equal, it means limit does not exist basically. Look, both the conditions represent what, dear? It represents limit does not exist. Because for limit to exist, we know that very well, LHL and RHL should be defined and should be equal to each other, right? But in this case, you can see they are both defined, existing in nature but not equal. They are not equal. What we can say about that then? It means limit does not exist. Even over here, now LHL and RHL are not even existing in nature. What it means? It simply implies that limit does not exist. So both this type of non-removable discontinuity is based upon what? Limit does not existing kind of nature. Got it? I hope this is clear to all of you. Okay, let's move on. Questions? Yeah. Question number 2. Does the following function have a removable discontinuity or jump discontinuity at x equals to 1? Okay, at x equals to 1. Have a look. Removable or jump, have a look. If I can find f of 1, what I'm getting over here, f of 1 is basically 3. F of 1 is 3. Okay. Now what about limit? What about limit? What about limit? So if I check over here, we can write here both LHL and RHL. LHL, RHL. Okay. So LHL will be what, dear? For this we have to use this part of function. So we have to use here 1 plus 2. How much is that? 3. This is my f of x at LHL. Okay, 3. What about RHL, sir? For this we have to use 1 minus 2. For RHL we have to use 1 minus 2. Think about it. This is the value 1. Right side we have x minus 2. Left side we have x plus 2. Right. So for the right hand side we have to use x minus 2. We get what? 1 minus 2. How much is that? Minus 1. So your LHL value is 3. Your RHL value is minus 1. What it means? Which type is it? Please check. Your limit exists. LHL and RHL. LHL and RHL exist but not equal. It means it is non-removable discontinuity of first kind. What is it? It is non-removable discontinuity of first kind. Again, this is not a question which will come in your examination in CET, but the concept is important. Okay, you should understand why it is not discontinuous. Okay, why it is not continuous actually. So from the non-removable type, we cannot change it now. If it was that f of a is not defined to limit, if it was like this, if f of a was not equal to limit, the first one, please check over here. Okay, not equal, then we'll call it as removable type. But this is not that case. This is the first case of non-removable type of discontinuity. Have a look. So let me erase this extra part. All right, clear? Okay, this is clear. Question number 2 is clear. Non-removable discontinuity of type 1 or first kind. Now question number 3. Discuss the continuity of the following function. Yes or no? Continuous, sir. Continuous. Okay, this also is continuous. Tell me why. Tell me why in the comment section. Okay, for question number 3, give me the comment. My question is why both are continuous. Why both are continuous? Give me the answer for this question. Why both sin x plus cos x, sin x minus cos x is continuous? Give me the answer in the comment section. There's one answer for that. Give me it and I'll cross check all of your comments. Question number 4 now. If fx is continuous for all x where this is given to us x cube x square minus 16x plus 20, okay, now to solve this question I can factorize it, right, because they're talking about continuous function, right? They're talking about continuous function. What happens in continuous function? What happens there? So your limit value becomes equal to function value at that particular point. Let's say in this case 2. All right, to find the limit value, where is the limit value going to come from? From this part, because function value at 2, have a look, is equal to k. So f of 2 is known to be equal to k. Okay, that is known now. So how do you find the limit value in this case? So there's two methods. Either you can apply L'Hopital's rule, or you can apply factorization in the numerator and something will be cancelled. You'll get the result from there. Okay, so you can what you can do over here is you can use synthetic method of factorization. From there, the synthetic division method you can use for factorization. Okay, if you want to factorize, you can use synthetic division method. Okay, this you can use, okay, to factorize the numerator. If you want to learn that, let me know in the comment section. In one of the session I will come up with and explain you this particular concept. Okay, this has been taught in grade 10 of any foundation classes. Let's say you're learning for foundation, you're preparing for JEE or any competitive examination, you learn this method in grade 10. If you don't know this method, do not worry, leave me if you want to learn this. It's a very handy method, it's very useful, and I'll teach you in the next class. Okay, so for now we can use L'Hopital's rule. Please check. So we're going to find the limit of the function, limit of fx when x tends to 2. How do you find that? Simply use this and differentiate under the limit. L'Hopital's rule says what? Differentiate under the limit and limit remains same. Differentiate the numerator, what you get? You get here 3x square. I hope you know why I'm differentiating, right? Because this is an indeterminate form. Please check. Put here 2, it will become 0. This will come out as 0 by 0 form. That's why I'm doing it. So we get 3x square for the first term. For second term we get 2x. Next we get minus 16. And over here I get 2 times of x minus 2. Even if you put the value of 2 right now, you'll still be getting what? 0 only. So let's try one more time. Okay, let's apply. What did I do over here? I applied L'Hopital's rule. L'Hopital's rule. Okay, applied over here. Again, let's apply the same thing. So we'll apply second time. Same rule we can apply second time. Okay. What I get? Same continues limit. What is it? X tends to 2. Differentiate once again. Differentiate once again. We get here 6x plus 2 divided by, we'll have what left? 2 times of 1, because this 2 will become 0. 2 times of 1. Okay. Continue from here. So I get limit 2 common, 3x plus 1 divided by 2. 2 and 2 is cancelled. X tends to 2. What is the answer? 3 into 2 plus 1, which is 7. And this should be equal to what? F of 2. What is f of 2? K. It means I get the value of k as 7. Option number A is correct. Option number A is correct. Works out for all of you. Is that easy? Question number 4. Answer is 7. Okay. So let's solve the next one. This is clear, right? This is clear. Any problem in this one? No? I hope not. Okay. If you have any problem, please leave me comment that you are having trouble in any of the part. Sir, I'm struggling with the L'Hopital's rule. I'm struggling with any of the things. I'm telling you, in the next session, whenever I see your comment, I'll come up with that part, and please watch that video. I'll give you the link for that video again in the comment section only. Don't worry. So question number 4 is done. Question number 5. Whatever I can do to help you out, I'll do that without fail, without even thinking for a second. Okay. Question number 5, 4th is done now. Class notes, don't worry, PDF format will be available in the WhatsApp channel. Join right now if you have not joined. If you have joined, good for you. Okay. Question number 5, if fx is continuous at x equal to 0, then what? Same approach we can apply. Apply here. So for the limit part, no, see, f of 0 is given as again k. Is given as again k. So for this part is clear. But for the limit part, I'll apply again same rule. L'Hopital rule. Okay. So what I get for this? Differentiate. Okay, basically limit of the function fx, I'll do that, x tends to 0, differentiate it under the limits. Okay. So we have numerator and denominator, so you can separately differentiate it. No need to apply the quotient rule over here. Okay. We get 5 times of e power 5x. That's a derivative of e power 5x. Okay. E power 5x remains as it is, and then if you differentiate 5x, it comes out as 5. Okay. If you don't know it, e power 5x derivative is going to be what, dear? You'll remain it as e power 5x. Okay, and differentiate 5x, you're going to get this as 5. That's why I've written over here 5 e power 5x. Okay. Let's continue the next step. We have minus sign. Put a minus sign, and we get same thing, 2 e power 2x. Same approach, right? E power 2x becomes 2 e power 2x. Alright. Divided by sine 3x will become cos 3x times of 3. Cos 3x times of 3. So derivative of cos x actually is minus sin x, and derivative of sin x actually is cos x. This sign you see over here is the symbol that we use for derivative. Some formulas I've given you over here. Works out. Now I think you can put the value 0 everywhere. Okay. When I do that, I get 5 times of e power 0 minus 2 times of e power 0 divided by cos 0 is what? Cos 3x, right? So cos 0 is 1. So 1 power 3. 1 power 3. Okay, no, not 1 power 3. 1 into 3, right? Excuse me. Not power 3. It's 1 into 3. 1 second, guys. I made a mistake. It's into 3, okay? So 1 into 3. So I get here 5 minus 2, right? E power 0 is 1. E power 0 is 1, right? So I get here 5 minus 2 by 3. Answer is simply 1. Answer is simply 1. Option D is correct. If you're getting a different answer, let me know. I'll ask you why did you get that answer. Answer is option number D, 1. If you got a different answer, give it to me. I'll cross check and we'll talk in the comment section. Question number 5 is done. Question number 6 now. These are the rules that I gave you how to do the differentiation if you don't know. Okay, don't worry, I'll teach you all of it. I'll teach you all of these differentiation rules. We started the chapter right now. Okay, but the question that comes for competitive examination, no, are like that only. They're mixed together. Okay, so if fx equals to kx square minus 2 for x less than 0 and 4x plus 1 for x greater than 0, continuous at 0, find the value of k. It's a homework. It's a homework. Okay, so from here, no, so to find the f of 0, right, put it in this case. You'll get here k times of 0 minus 2. You get over here minus 2k. This is my value of f of 0. Okay, and to the limit part, right, I'll give you the hint. For the limit part, you can use this function, this end. X tends to 0. Solve it and give me the answer. Comment the answer. It's a homework. Please comment the answer. Okay, can I move on to the next question? Question number 7. Seventh one. Okay, in this case we have two variables, same approach. Yeah, the given function is continuous. We have to find the two variables a and b. Find the two variables a and b. Alright, let's apply limit equals to the function. So we're going to do for 1 first. We're going to do for 1 first. Okay, let's do it over here for 1. So we know that f of 1, from here we can see f of 1 equals to a. How come, sir? Check this equality sign over here. X greater than equal to 1. It means equality is present over here, right? Here there is no equality. It means f of 1 is equal to a. Okay. Now limit we'll have to find out. Limit we can find from here for 1. Alright. So if you find the limit from here, I get limit x square by a when x tends to, what is it? 1. When x tends to 1 is how much? It's going to be 1 by a, right? It's going to be 1 square by a. How much is that? Simply 1 by a. What did I say? They said that they'll be equal. It means 1 by a will be equal to f of 1. And what is f of 1 given as? A. From here what I get? I get 1 equals to a square. So I'm getting a square as 1. It means value of a will be plus 1 and minus 1. Value of a will be plus 1 and minus 1. Is that clear? Is that clear? Have a look. Okay. Now for the next part, for the variable v. Okay, for the variable b, I'm going to use the value at root 2. Okay. So f of root 2 is how much? Check from here. F of root 2 is clearly what? It's clearly from here. What I get? 2b square minus 4b upon square of x. Upon square of x. So root 2 square. Root 2 square. Let's simplify over here. So I get f of root 2 as, have a look, 2b square minus 4b divided by square of root 2 is simply 2. Cancel this 2 and here also cancel with 2. My answer is coming as b square minus 2b. b square minus 2b. And this f of root 2 is equal to what? This f of root 2 is equals to limit. This is equals to limit of the function basically, yeah, fx when x tends to root 2. And how much is that? We can find this for the limit, right? Root 2 not equal to over here. I can use the limit condition. So I get this equals to a. I get this equals to a. Have a look. So I'm getting what? I'm getting b square minus 2b equals to a. Minus 2b equals to a. Alright. So if I look at the value, what I'm getting over here, I get from here b times of b minus 2 equals to, if I take here 1. If I take here 1, okay. Even I don't think we need that. I don't think we need that. We'll use the options directly from here. We'll use the option directly from here. If you put a as 1 and b as 2, it will become 4 minus 4. So it will not be true. Option A is wrong. Correct, na? Use over here option in the given statement that we got. Use the first option. A value is 1 and b value is 2. What I get? B square will be 2 square minus 2 into 2. 4 minus 4 is 0. So not true. Second one. A1, B1. Use B value as minus 1. We get here 1 minus, so we get 1. Square of minus 1 is 1 minus 2 times of minus 1 becomes plus 2. How much is this coming as? 3. But A value is 1. It means option B is also wrong. Apply. Okay, now check the option number C. B is 1 and A is minus 1. B is 1 and A is minus 1. Let's apply this and check whether it is satisfying or not. Okay, so we have A is minus 1, so we can use B, right? We'll have 1 square minus 2 times of 1. How much is this? 1 minus 2, how much is this? Minus 1, means A value is minus 1, correct over here. So option C is correct. Option C is correct for question number 7. Have a look. So we had to use here options to get the right answer. Is that clear? Is that clear or not? Have a look. Question number 7 is done. Option C is correct. Option C is correct. Okay. Question number 8 now. Class notes you will get in the WhatsApp channel. Question number 8 now. Fx is continuous at x equal to 0 where they given the function. Okay, f of 0 is equal to what? Same condition, f of 0 will be equal to limit of fx when x tends to 0. As simple as that, because they have said that it is continuous at this particular point. How do you find limit? Of course, we can apply L'Hopital's rule. You can apply L'Hopital's rule. Okay, have a look, differentiate. Okay, under the limits, what we do in this case? Differentiate this, right? We have 1 plus x power 1 by 2 in the first case. This represents cube root. Okay, so we'll write over here minus 1 plus x power, right? 1 plus x power 1 by 3 and divided by what I have? X. And when we write here, x tends to 0 also. That's what the limit is. Differentiate under the limit. So again we'll repeat like this, x tends to 0. We get here 1 by 2 and this 1 by 1 plus x. 1 second, I got it wrong. Yeah, this 1 plus x now will come in root but in the denominator. 1 plus x, 1 plus x. Okay, and then again there's subtraction over here, 1 by 3 will come, and again you'll have a root in the denominator, 1 plus x, and derivative of this denominator will be x derivative, simply 1. Got it or not? Very simple. Substitute x value as 0 now. Substitute this x value as 0. What are you going to get? You will have answer as 1 by 2 minus 1 by 3 by 1. So we don't have to write that. LCM is 6, 3 minus 2. 1 by 6 is the answer. Option D is correct. Option D is correct. Have a look. Have a look. Put x value as 0, it will become root of 1, right? Root of 1 is what? 1 only. 1 by 2 into 1 is how much? 1 only, right? So 1 by 2, same goes with 1 by 3 also. So minus 1 by 3. Divided by 1, again we don't have to write that. Difference of that is 1 by 6. Option D is correct. Question number 8 is done. Question number 8 is done. Question number 9 is your homework. It's your homework. You're going to leave the answer in comment section. Comment your answer. Comment your answer. Okay, what are you going to use? Same approach you can use. Approach is L'Hopital's rule. What it means is differentiate numerator and denominator individually under limits. And finally substitute the value of x, which is given in this case as x as 0. So it will become what? Limit of the function fx when x tends to 0. Do it and let me know the answer. Question number 9, what you are getting. Okay, question number 9, I want the answer from you. I've given 2-3 homeworks. Please complete it. Question number 9 is done. Question number 10. 9, don't forget to give me the answer. Very strictly, I want all of the answers, and at the end, I want from all of you how many questions you got right and how many you attempted. Okay, I want to see the progress been made by all of you. I'm here accountable for that. I want to know everything that is going on right now with the mathematics. Okay, question number 10. If f theta continuous at theta equals to pi by 4, where the 1 minus sin theta, okay, this is given, k equal to what? What we're going to use? Same thing. Limit x tends to pi by 4, f of pi by 4. What is f of pi by 4? K by 2. f of pi by 4 is k by 2. Let's find the limit now. So we get limit 1 minus tan theta divided by 1 minus root 2 sin theta when theta tends to pi by 4. If you want to substitute right now, you'll have 1 minus 1 in the numerator and 1 minus again 1 in the denominator, which is 0 by 0. This is called as indeterminate form. So we're going to do what? Apply the L'Hopital's rule, differentiate under the limit. For 1 will be 0, for tan you'll have sec square theta divided by, again 1 will be 0, minus root 2 will remain as it is, sin will become cos theta. Okay? Write the limit one more time. Now this time have a look, minus and minus cancelled. I get here sec square, what is it, pi by 4 divided by, what is it, root 2 cos of pi by 4. Okay, sec square pi by 4 is what? Sec square pi by 4 is root 2 square. It is root 2 square. Cos pi by 4 is 1 by root 2. So sec will become 1 by root 2, simply root 2. So root 2 square. And for this we'll be having what? Root 2, and cos pi by 4 is, as I said right now, 1 by root 2, cancel. I have the answer as square of root 2 is how much? 2. This is my limit value, right? And this should be equal to what? K by 2. Should be equal to K by 2, right here. Equal to K by 2. So I get the answer of K as 4. Answer for K as 4. Option D is correct. Option D is correct. Is it clear now? Option D is correct. Okay. Simple question. Was it difficult? Was this question difficult? No, right? Okay, fine. Question number 11. I think this is the last question of the day. Let me solve it and give it to you, the final answer, and we'll conclude the session. Okay, I hope you learned the continuity, how to solve questions in continuity. Again, these all questions you see are of the type this is asked in the KCET examination. Okay, so very, very important to you. Don't worry, I'll give you the PYQs also, but this is again very, very, very important. Find the values of a so that the function f is defined like this is continuous. What it means? Same approach. Limit of the function x tends to 0 equal to f of 0. What is f of 0? 1. Right here, 1. Okay. Limit for this, limit sine square ax upon x square when x tends to 0. Now if you remember, there is a standard limit, right? Sine square ax by a square x square limit x tends to 0 is given equal to 1. This is the standard limit. Okay, but in this case what is missing? We have a square missing from the denominator. So let's do that change. Let's make that change. What we have? We multiply here a square in both numerator and denominator. Let's see what is going to happen. So we get here limit, this is a constant, I can keep it outside, right? A square is a constant, I can keep it outside. So right here, a square limit sine square ax upon a square x square when x tends to 0 equals to 1. Now if you use this property, you get this limit will be what? This will become equal to 1. From here you are getting a square times of 1 equal to 1. It means a square equal to 1. It means a equals to plus minus 1. Got it? Question is a equals to plus minus 1. Option C is correct. Is that clear? Have a look. Question number 11, option C is correct. Okay, simple question. I hope you got it. So please don't forget to give me answers for all the questions that I've given you as homework. And this is it for the session today. I'll see you again very soon in the next session. I want you to give me 2 comments. Again, one thing is how many questions you have completed and all the answers of all these questions. Okay, with this I can end the session today. I'll see you again very soon. Till then, take care. Bye-bye.